review now. I gave you some simple dimensional analysis problems. You didn't know you were doing dimensional analysis, but you were. So if we go ahead and take a peek at this, you can see that you had something, you were given something. So in this situation, you were given 3 dozen oranges. So this will take you all the way through what we're learning now, which is called stoichiometry. You underline what they give you, and then you circle what they want. So in this one, we're going to circle oranges because they want oranges. In the next problem, you're given 10,000 pounds, and then they want tons. In the next problem, what should I underline, please? Maria.
Years.
So 4 years, and I'm going to circle hours. So when you, especially if you struggle with like word problems and you don't know where to start, but when somebody tells you how to start, you can do it. This is how to know where to start. You underline what they gave you, and you circle what they want. So I'm going to work these out, and I'm going to use dimensional analysis. So the first one is 3 dozen oranges, and I'm solving for single oranges. So I'm going to go back to this other side. And so if I have 3 dozen oranges, because that's what I had underlined. Notice when I write it down, I underline it. That's why I underline it. You write it down, and then it's on the top of a fraction. And then this will work every single time. You know in math class where you can cancel, like cross cancel, so I can cancel here and here. You know what I'm talking about? Like, it's not there yet, but I can cancel that. So whatever's on the top of that first fraction needs to go on the bottom of the second fraction. So I'm going to put dozen oranges. Oops, I'll put 1. So you got 36 because you put 1 dozen, and then up here you put 12 oranges. Maybe that's not what you showed, but you multiply 3 times 12. This is, in dimensional analysis, how you would show that work. So this is great for things that you can't think about in your head. And then we had circled oranges. When you have what you want in this top right-hand corner, then you know you're done. Now, in math class, can I just take a number like 3 and just pull 12 out of nowhere and multiply? You can't do stuff like that, can you?
Yeah.
So let me tell you what. In math class, can you multiply by 1 and not change anything? Yeah, you can. So look, 12 is a dozen. This fraction right here, that right there doesn't mean anything except 1. That's why I can do this. That's why dimensional analysis works. Because I'm taking something, and it's dimensional analysis's purpose is to convert units. So you can't just change values of I'm going to systematically multiply things that are 1. So the top of that fraction needs to be equal to the bottom of the next the bottom of the fraction. So in the next problem, we had underlined 10,000 pounds, and we had circled tons. So if I go over here, so 10,000 pounds, I'm going to write it with a line under it because I underlined it anyway. What needs to go on the bottom of the next fraction, Katie? What unit? It's really revolutionary, right? This whatever's right here, you need to put on the bottom of the next fraction, no matter if there's 4 fractions. You just keep doing that so you know where to go. And I gave you that 2,000 pounds was 1 ton, and I was looking for tons. When what you're looking for is on the top of the next fraction, then you're good. This skill would take you through physics, AP chemistry, AP environmental. You see how I'm talking about it like I really know what to do, and I'm telling you like exactly?
Yeah.
Because you know how many times I've taught this lesson, like a bunch. This skill is good for every science class that you'll ever take. Right? This is like your bread and butter forever. Most math problems can be solved this way. And if you take it a PSAT tomorrow and it wants you to convert, this is the way to do it. So anyway, when you divide 10,000 by 2,000, because a fraction is division, that's 5, and the only unit left is tons, because this cancels. Okay? And then that last one, it was asking how many hours in 4 years. I had underlined 4 years and circled hours. So, I'm going to start by putting 4 years on top. Now, I want you, on your paper, to work it out like I've been working out and get your answer that you got on the do now when you just kind of did it in your head. So, show all the units and all the numbers. If you just write down 24 over 1, I'm going to lose my mind. Because that'll be what causes you to fail. Okay? Every time you write a number down for me for the rest of eternity, it shall have a unit. Thank you. Also, nothing ever goes on the bottom of that fraction at the beginning. This will always be over 1. There's a couple problems in physics where that might not be true, but you ain't in physics. Okay. So, go ahead and tell me. You guys got it, by the way?
Yeah.
Okay. So, Mark, since you said yes so well, why don't you tell me what I need to put on the bottom of the next fraction?
1 year.
Okay.
And then 365 days.
Okay.
And then
Hang on.
4 hours over 1 day.
1 second. There. Okay. So, look, make sure each time you do this, every time, because sometimes I'll be working out problems on the board, and every time I write a fraction, I'll make sure it cancels, because sometimes I'll write the fractions upside down. Like, because if you put 365 days on the bottom and you're not paying attention, then you're going to get a completely wrong answer, because your units don't cancel. But look, 365 days is 1 year. This is equal to 1. That's why I can do this. And then on the bottom one, here I did.
1 day.
Okay.
And then 24.
And then that's what I was looking for. When what you're looking for is in the top right-hand corner, then you know you're done. Okay. So anyway, you multiply all that out and you get something thousand. What do you get?
35,040.
Is that what I've got?
Yes.
All right, cool. So that's dimensional analysis. Now, we're going to kind of continue this, and we're going to start talking about molar mass and molecular mass. So, I have this little molecule right here as water, okay? So, one water molecule, okay? So, the H2O. If I find the molecular weight, notice how I'm using the word molecular. Water is a molecule because it's covalent. Do you remember how ionic things aren't molecules? Ionic things are called formula units. So like this sodium chloride, that is a formula unit. Water is a molecule because it's covalent. Sodium chloride is a formula unit because it's ionic. So that's just a review, like from last unit. Okay, so if I wanted to find the molecular mass, this I'm talking about like 1 molecule of water. Like 3 atoms, okay? Y'all already, did you see this yet? This paper clip right here is a gram. That weighs a gram. Atoms never equal grams. That don't make sense. Because you know there's more than 1 atom in the paper clip, right? Okay, so when I'm going to find the molecular mass, I'm going to add up the mass of 2 hydrogens. So I have 2 hydrogens times. Yes?
Pardon the interruption. Is this Daniel Jones in class?
Yes, ma'am.
Could you send him to the front office, please?
Yes, ma'am.
Thank you.
All right, so I have 2 hydrogens, and then we're gonna round these masses on the periodic table to 2 decimal places. So 2 times 1.01, and then if it's 1 atom, is the unit grams or AMUs? Thank you. So that equals 2.02 AMUs. Okay, and then I have 1 oxygen, so that's 1 times 16.00 AMUs. And so the molecular mass of water is 18.0 AMUs. Now, y'all did the stations yesterday, and you were tasked with measuring out a mole of water. Were your units AMUs? No, they were grams, because if you have 6.02 times 10 to the 23rd, which is 6.02, and then 21 zeros. If you have this many molecules, then whatever's on the periodic table, will you be able to write down grams. But this 1 molecule sure ain't that. So you don't need to get AMUs and grams mixed up because they couldn't be farther apart. Okay? A paperclip is a gram. A proton is an AMU. It's a big difference. All right, so the molecular mass is this many AMUs. The molar mass, so 1 mole gives you molar mass. So now I'm talking about a whole bunch of particles. And the unit for this, we're just going to do the same math. I added up the same. The unit for this for water will be 18.0 grams. So when you have a mole of something, that's when you're going to start having grams. When you have a single particle, AMUs. You kind of get the difference. It's a piece of cake, right? So anyway, I do want to show you when you have more complex things like, let's say I had barium phosphate or something. If I give you barium phosphate, first of all, you better make sure it's neutral because you're about to mess up your math. Okay? So phosphate's 3 minus, barium's 2 plus. Is this going to be a molecular mass if I do 1 particle? Is it a molecule? That's ionic. So what I'm going to have to do here is I'm going to find the formula mass. Because if that's ionic, it's a formula unit. Okay? So it's still 1 particle. So to do this, I need to have 3 bariums. So barium's mass is 137.33. So I'm going to go 137.33. That's AMUs times 3 plus how many phosphoruses? 2, that's right. So phosphorus's mass is 30.97. And then I have how many oxygens? 8. You see how I'm doing this? This is just like how you count it up when you're bouncing equations. So I got an 8 times oxygen, 16. This is AMUs, and this is AMUs. So now take your calculator and calculate up for me the formula mass for barium phosphate. Tell me the formula mass for barium phosphate, Katie.
I got 601.48 grams per AMUs.
Is that what y'all got? It's pretty heavy. Wow. Did you get this?
Yeah, I got it. Doesn't really matter. Like points.
Oh, the decimal places I'm not stressed about.
Yeah, we got.
Okay. So I'm just looking for something around 601 and then the decimal places. When you put it into your calculator, just go ahead and round it to your decimal places. Okay. And then the molar mass, Katie, do I have to do anything different?
You just change the units.
So now I'm going to change the units to grams. Are we crystal clear on formula mass versus molar mass? So like, if I ask you to find the atomic mass of carbon, you would tell me 12.011 AMUs. But if I ask you to find the molar mass of carbon, you would do 12.01 grams. So same idea, that's easier. So you have formula mass, atomic mass, molecular mass. Those are AMUs. Molar mass, when you have that many particles, is going to be grams. Okay, so there's that. All right, now we're going to come back to the notes after you do a little bit of practice with this. So go ahead and get out the work from yesterday, and we're going to start with number 6. What you're going to do with your hand is I gave everybody a brown dot on their hand. And what does that look like?
Mold.
It looks like mold. So go ahead, it does look like chocolate as well. Go ahead and write mole on your palm. Got it?
Yep.
You don't need to talk, just write. Okay, now, when we had just talked about molecular mass or formula mass or atoms, this is FAM, formula mass, or excuse me, formula units, atoms, or molecules. So formula units, which is ionic, atoms, which are atoms, and molecules, which are covalent. So these are single particles. So this finger right here is particles. And I call this the Avogadro family. Avogadro's number is 6.02 times 10 to the 23rd. That's his family. This is his finger. Everything on this finger, when you're using this finger, is going to get Avogadro's number. So this box I have here represents a mole. And if you look at this box, a mole is always 6.02 times 10 to the 23rd. Molecules, formula units, atoms, and molecules. Okay? So this number is Avogadro's number. This is his finger. This is his number. Formula units, atoms, molecules. When you're doing anything with this first finger, you're going to use this number. That will be the only time, because this many grams weighs more than the moon.
Yeah.
Okay, so that's one part of a mole. So that equals a mole. Another thing that we can equal to moles is grams. So grams from the periodic table. So if I find the molar mass, adding up the atomic masses from the periodic table, and then if I know I have a mole of them, right? So for example, a mole of hydrogen is 1.01 grams to mole. So if I look on the side of this block, this box is a mole. The other side of this box shows how a mole is also like a helium is 4 grams. A mole of oxygen is 32 grams because it's O2. That would be the molar mass of those things. That's also a mole. Now this box, its volume is 22.4 liters. That's why it's that size. Yes.
Wait, so is a mole just double, but
So these things are diatomic.
yeah.
That's why it's got doubled. O2 is 32 because 16 plus 16. There's 2 oxygens. Okay, so this other finger right here, there are 22.4 liters in a mole. That's new. I hadn't told you that yet. So if I have a guess, if I filled this box up with oxygen, it would be 22.4 liters, and that would also be a mole, which would also be 6.02 times 10 to the 23rd particles, which would also be one of these masses. If I filled this up with oxygen, it would weigh 32 grams of oxygen, okay? All those are the same. So on this finger right here, I'm going to write down liters. So when I'm using this finger, I'm going to be using 22.4 liters. So we're not going to get to that today, but at least you know. All right? So that's what I'm going to be using. And then I'm going to show you how we're going to do these conversions. So what I had showed you earlier with the dimensional analysis now comes into play. So let me give you, I'm going to do 3 examples for you. Example number 1. So basically, if you're reading a problem and it said, a sample of carbon contains 8.21 times 10 to the 24th atoms. How many moles are present? So write this down, and I want you to underline what you're starting with, and I want you to circle what you're solving for, just like we did on the do now. There was a reason I made you do that easy do now. My battery in my pen's starting to go out. I'll replace it. I'm not get done talking. Okay, what did you underline, please? Katie, I picked you again. Sorry.
8.21 atoms.
Cool. What should I circle, Anna? Yeah, and that looks really like a mess, so I'm going to fix it. Moles. Yeah, so just moles. So what unit am I looking for? Okay, so what we're going to do is we're going to look at our hand. I had a lot of people out in first period today, so I recorded it. We'll see if they watch it. But I'm going to look at my hand, okay? And I'm going to find where I'm starting. Which finger am I starting on? Hang on, look, don't guess. Let me help you out. I'm going to take what I underlined and write it. And I'm going to write the units and I'm going to write the substance. And you're going to do that too. Atoms of carbon. It's very important to write both. So if I look at my hand, everybody hold up the finger. Actually, just point to the finger. We don't want to always hold the fingers. You know what I mean? It's going to be like a here. Point to the finger you're going to be using. Yeah? Yeah, there you go. So we're going to start with this finger for formula, units, atoms, and moles. And so, molecules, sorry. To get to moles, see here? I'm just going to go to my palm. So this is going to be a one-step conversion. I know I'm just going from here to here. So, what needs to go on the bottom of that next fraction? What unit, everybody?
Carbon.
Yeah. Atoms of carbon. And whatever you're pointing to, like if you're pointing to moles, moles need to go on the top of the next fraction. Yes, sir.
Can you move that box so I can see?
Which?
Like the mole right on your desk.
Oh, the giant one?
Yeah.
Sorry about that. Sure thing. All better?
Yeah.
Okay. So whatever I'm pointing to, in this case moles, goes on the top of the fraction. So I have 1 mole of carbon. 1 mole of carbon is equal to how many atoms? Please tell me. Think about your answer, Quinn. What did I tell you we were going to use every time we use this finger? This is Avogadro's family. It's Avogadro's number.
So 6.02 times 10 to the 20.
Sure. So, I'm going to see if my units cancel, and they do. And then moles of carbon is up here. And when you have the unit you want in the top right-hand corner, which I do, then I know I'm done. Okay? So, what you're going to do in your calculator, you need to use parentheses. You're going to go, I can't get it to another code. You're going to go parentheses, all of that, divided by parentheses, all of that. And I'm going to get another battery for my pen because it's dead. And then make sure that you are showing your units and the substance. So your answer should say moles of carbon. Got a little hasty with myself. Don't know. Do you guys get it? Okay. That was right. One second. Alright, so what did you guys get? Please tell me. Will, what was your answer?
13.64.
Okay, so 13.64 moles. Did you guys get that?
Yes.
Who said?
I got 130. Oh, I'm just kidding.
So, okay. In your calculator, did you use parentheses?
Yes.
So parentheses 8.21 times 10 to the 24th, post parentheses divided by parentheses 6.02 times 10 to the 23rd. If you did that, so who did get this? You probably put in your calculator wrong. Do it again. Okay? So take a second if you need to shoot to do this one again. So that's a one-step conversion. we need to do some two-step conversions. Let's do one more one-step though.
Wait, does it go like wait, sorry, middle fingers?
What's the correct answer?
We'll get to that, so don't stress yet.
Okay.
So we'll always wait.
Alright, here's example 2. Write it down. So, in a sample, oh, sorry. What is the mass of a 3.2 mole sample of, I don't know, let's say fluorine gas. So F2. So underline what you're looking for, underline what you're given and circle what you're looking for. Okay, so what am I going to underline, please? Jake?
3.2 mole.
Yep, and then what am I going to circle?
Mass.
Which that will be grams, right? Okay, so let's look at our hand. So we're going from our palm, which is moles. So we're going for moles, and then we're going to solve for grams. So that's a one-step conversion, and it's grams from the periodic table. So I'm going to write down what I'm given. And this is F2. Without even knowing anything from today, what do I need to put on the bottom of the next fraction, Cora? It's always the same as the one before it on the top. So whatever is on the top goes on the bottom of the next one.
Mole.
Yeah, so moles of F2. And notice how I'm diligently writing out not only moles, but also the compound. Be very careful about that. So 1 mole of F2, and then I need to go, okay, so I'm going from I'm going from moles to grams. So that's one step, okay? How much, or what is the mass of 1 mole of F2? Can you figure that out? So do it, write it up there. Right, F2, what's the mass of 1 mole of F2? What's the molar mass of F2?
37.
It'd be 19 times 2, which is 38.00. You can round to 2 decimal places. Does everybody agree with that? Yeah. So 38 times 3.2 would be 76 plus 38 more, which would be 104. 2 would be 7.6. I forgot what I said.
So is this like the intro to the whole like page?
Yeah. What did y'all get when you used your calculator? 121.6 grams F2. Are you lost? Are you sad? You are sad? I mean, it's really not that bad, right? Let's do one that has 2 steps now. Okay? Example number 3. How many molecules are present in 87.12 grams of water? So write this down, underline what you've given, circle what you're looking for. Okay, Anna, I picked you again. What am I going to underline? I'm going to circle molecules. So I'm solving for molecules. So here's my hand. Here's moles. I'm going to start at grams, which is here. I got to go to moles. Then I'm going to go to molecules. So look at your hand. Start at grams. Go ahead and start with grams. Like, go ahead and write it 87.12, whatever you're given is where you start. 87.12 grams of water. Put it over 1. Before I do anything else, by default, every time you do dimensional analysis until the day you die, which for some of y'all are going to be doctors, are going to be forever, Kyron, what units need to go on the bottom of this next fraction?
Grams H2O.
Y'all kind of seeing what I'm saying about that? Alright, cool. So, I started on this finger. The one that I'm going to point, I can't just hop over fingers, okay? So I got to go to my moles next and then to molecules. So, whatever you're pointing to is what goes on the top of the next fraction. So, I'm going to put 1 mole of water. 1 mole of water has how many grams in it? It ain't going to be Avogadro's number, I'll tell you that right now. 18.02. We've already done that today. Do I need to show you that again? 1 hydrogen plus 1 hydrogen plus 1 oxygen. That's 18.02 grams because it's a mole. Now you good?
Yeah.
Alright, cool. So, sitting here, you're at moles. We got to go to molecules. So we're going to this first finger. Okay? So whatever's I'm pointing to needs to be on the top of the fraction. And whatever's on top of the fraction before, let's see. Well, I'm going to put down here on the bottom of this next fraction. You see how hard this is, don't you?
Yeah.
This is what makes people fail chemistry. It's a true story. It's not that bad, right? I did not understand this when I started trying to do it when I was a kid. Alright, 1 mole of water. I am pointing to molecules. So the top needs to be molecules. Do you understand what I'm saying? I'm pointing, that's where I'm going. I went doot, doot, doot. That's where I am. Whatever I'm pointing to is what needs to go on the top. So I have molecules of water. This is Avogadro's little family finger right here. How many molecules are in a mole? Alright, so that's as hard as it's gonna get. Is that bad?
Well, that's not really a page. Is that all?
We're gonna have to do some stuff with the reactions. Yes.
Is there an abbreviation for mole?
There's an abbreviation for mole, which is MOL. There's not an abbreviation for molecule, which is hilarious. I actually got tweeted and kind of got like little tiny things for that because I was like, anybody else think it's funny that there's an abbreviation for mole and they drop the E, but there's not an abbreviation for molecule, which is a much longer word.
Honestly, they scam mole.
Scam. Okay. So anyway, grams cancel. I had a little quote in a magazine. You know, at the end of the magazine, they'll have little quotes. True story.
Really?
Yeah. And that's what I was looking for, is molecules. Alright, now, listen to me. When you put this in your calculator, you're going to go 87.12 times, parentheses. Anytime you have something with exponents, you got to use parentheses. Parentheses, 6.02 times 10 to the 23rd. Close the parentheses, hit equals. Divided by 18.02 equals. Try to do that. I'll get the answer and I'll write it up here. Make sure we get the same thing. Is that what you got? Did you see how I wrote molecules and I wrote water? You remember, okay, go back in the time machine of your mind to yesterday where I was like, I'm on B -1 if you don't put an S on the precipitant. Do you remember me telling you that? Do you know how many of y'all didn't get 100 because you didn't put an S? About 5 of y'all. So I'm telling you right now, you don't put an S, you not get, or you not put the substances, you're not going to get credit, okay? Yes, ma'am, sir. Sorry.
How are you supposed to write it in the calculator? Because my numbers were always not.
Okay, so in your calculator, if you're struggling with calculator, 87.12 times parentheses, then hit 6.02, then hit the second button, and then hit that EE. See the EE? It's on top of the X and then -1. X is above 7. Okay, hit that button. You get an E in your calculator. Then hit 23. Then close that up parentheses. Now hit equals. Now divide it by 18.02. Got it? Okay. I'll come help you in a second, okay? What are you switching? Close it up. Divided by 18.02. Okay. Alright, you want to trauma by yourself? Well, you have to anyway, I don't care. That's okay. That's okay. Is this for a grade right now? Am I going to get mad at you if you know how to do it? No, I don't care. We're learning. Oh, now, I'll do a one step with you first, okay? Let's just do one step. How many atoms are present? Did we do one like this already? Maybe. They're all the same. Present in 7.33 moles of aluminum. Am I just making stuff up?
Yeah.
I've been doing all semester. Have you ever seen that piece of paper in front of me? Nope. Sorry.
So all those
Keeps
examples
it fun.
are fake?
Huh?
Nothing.
All the notes you've ever taken are fake. Is that what you said? Where am I supposed to get them from? Chemistry teacher? Okay.
Well, at least you're not a teacher that's like going on the internet, downloading worksheets that they can't even do.
True.
Makes your class do it.
Alright, so underline what you're given. Hush your face. Underline what you're given and circle what you're looking for. And then do it. Do it to it. Use your hand. And don't you dare pack up. We have 4 minutes left. It should take you 2 to do this. That's you. Take what you're given. Put it over 1. Put the unit that you're trying to cancel on the bottom of the second fraction. When you write your answer, make sure you have units and the help. Nelson, did you get it finished? Almost done? So start to talk me through this, Chi-Chi. I'm starting with 7.33 moles of aluminum. Anybody lost yet? What needs to go on the bottom of the next fraction? Of aluminum. Okay? And then I'm looking for atoms. So I'm pointing to the finger. What did you put on the top, Chi-Chi? Okay, so do you understand that it's going to be atoms? Because, I mean, that's where I am. How many atoms are in a mole? Do I have what I wanted in the top right hand corner? Oh yes. So this one step, that's it. So you're going to take 7.33 times 10 times 6.02 times 10 to the 23rd, and that's it. So when you do that, don't pack up yet. Let's just do it real quick, get it done. You have it in your notes. 7.33 times. You get 4.39 times 10 to the 24th atoms of aluminum. Is that really that bad? Really that bad? It's okay. It takes a couple days. You're fine. If you don't totally get it, I'm not giving you homework. I'm not mad that you don't understand. We're gonna keep practicing.